Today's lesson is about even or odd function. What's even function? You can think about even exponent. For example, for all power function with an even exponent will be even function when you have y equals x squared or x to the fourth power. Keep going, we can write down x to the 2nth power. For odd function, think about the power function with the odd exponents. So we have y equals x, or x to the third power. We can write down x to the 2n minus 1th power. On the graphs, I plotted two functions here, y equals x squared and y equals x. I will use these two functions to explore the property of even and odd functions. First of all, look at these two graphs. For y equals x squared, this graph reflects across the y-axis. For y equals x, it's reflect across the origin. How do you know the graph is reflecting across the origin? When you rotate the graph 180 degrees, you will get the original graph. This kind of graph we say is reflecting across the origin. So when you rotate the graph of y equals x 180 degrees, you could say the graph we get is the original graph, y equals x. Second property, think about f of x equals x squared. When we have f of negative x, you will get the negative x squared. That is x squared equals f of x. So for all even function, we have f of negative x equals f of x. Basically, this is the definition for even function. For f of x equals x, we have f of negative x equals negative x. We can write down negative f of x. So we have f of negative x equals negative f of x for odd function. And then for third one, let's explore the graph of cosine x. We could say the graph of cosine x is reflected across the y-axis. So we could say cosine x is an even function. For sine x, if we rotate the graph of sine x 180 degrees, we will get the original graph of sine x. Therefore, sine x is an odd function. Therefore, for cosine x, we have this property, cosine of negative x equals cosine x. While for sine negative x equals negative sine x. Therefore, let's explore integral from negative pi over 2 to pi over 2 of cosine x and sine x. For cosine x, we know this is the definite integral from negative pi over 2 to pi over 2 cosine x dx means this part. It will be equals to double this part, which means 2 times the integral from 0 to pi over 2 cosine x dx. For integral from negative pi over 2 to pi over 2 sine x dx means this part and also this part. The first part is a continuous positive function. So your answer will be, suppose if this one is positive a, then for this part will be negative a. So we add together will be 0. In other words, for calculus level, you will have integral from negative a to a f of x dx. It will be 2 times the integral from 0 to a f of x dx. For odd function, definite integral from negative a to a f of x dx, you will get equal to 0.